All right, I think we are ready to start. So first of all, welcome. I'm super happy to be here because, well, it took me 18 hours to get here because you can probably say I'm not US-based. And I will tell you a couple of words about myself in a minute. But first, I want to tell you a couple of words about what will be the topic of this presentation. So I'm going to talk about library I co-create, which allows you to build live activities and widgets in React Native with no native code changes. So my name is Szymon or Szymon, if you are brave enough to try to pronounce that. And I work at Callstack as React Native expert. Basically, my day-to-day work includes working on many open source projects. I created a couple of them. One of them is, for example, Rosenite. Maybe there are people using Rosenite in their day-to-day work. It's basically a way to extend built-in React Native DevTools with custom panels. So you can have, for example, Tanstack Query DevTools included in the built-in React Native DevTools. I also built Harness, which is a way to run your tests, which are built in JavaScript, on a real device inside of a real React Native application. So you can access all the native protocols available in your application. And then, last but not least, we have, which is the topic of this presentation. So the story of Voltra started with this tweet from Saul Sharma. So basically, he thought that there must be a way to drive live activities and widgets with JavaScript. And he created some, let's say, POC and sneak peeked it on X. But then he struggled to finish it, basically. So we, as Callstack, we reached out to him to basically offer him our help. And that's how Voltra was born. Right now, you can download it from NPM. You can use it in your projects. It supports both iOS and Android, so you can create live activities and widgets for iOS and widgets for Android. You can have them updated remotely via push notifications or, for example, by pulling data via HTTP queries. And there are no manual code changes needed. You simply use expo config plugin provided by Voltra, and then it's basically working out of the box. So to use Voltra, you just need to install it, like favorite package manager you like. Then you need to add the Voltra plugin to your app.json config. And then, well, you are good to go as long as you call pre-build. Because at this point, you can write, well, components looking like React Native. Because if you look at this snippet, it's basically React Native. Like, there's a difference. Because we are not using normal views. We are using Voltra HStack, for example. The pattern there is that Voltra basically gives you access to native primitives of given platform. So for Swift, for iOS, it will be basically HStack, VStack, text, and other things like this. But if you look closely at the style property, the value is omitted because it will make the snippet long. But you can trust me, this is normal style sheet object you use in your React Native apps. So technically, there's nothing you need to learn to use Voltra. You can just use your knowledge of React Native. Then the next nice feature of Voltra, especially when it comes to live activities, is that if you change something, it will be automatically updated on the native side. So basically, we have hot reload for live activities, which is not the case with native code. And all of this can seem magical, like thousands of lines of code, like, I don't know, months of work. But in reality, it's basically clever engineering. Like, we took a couple of components that already exist in the ecosystem. We took React, some patterns from React Native. We took native frameworks. And in the end, we had to create this glue, this custom renderer, which will combine all these pieces together. And the idea for this presentation is to go through the process of creating Voltra yourself. Step by step, we will revisit all the problems I had and Saul had while working on this project. So let's start with some requirements. First of all, we want to transform JSX, JavaScript, into native UI. We will focus on Swift for this presentation. And we need to support dynamic island. Why? Because Apple forces you to do so. If you start live activity, you need to provide variants of your UI to be presented in the dynamic island space, because if you don't, well, it will be just black space. We cannot force users to do rebuilds, or we cannot force users to use any userland Swift. No native code. That's the rule. And the last part, we need to support remote updates, because if we treat the app as a single source of truth, then basically if the app is dead, our live activity is also dead. So we need alternative. First, we need to talk about React and how we build our applications with React. And the most important thing is that we build our applications as trees. So we have the root node, we have some custom components we write, and then at the bottom, we have host elements, host components, which are primitives of given platform. So we can say that React is basically converting our custom elements, custom components we write, into some kind of, let's say, representation, including only host elements, those primitives of given platform. And then this is the work of renderers to take this blueprint and convert it into native UI. So basically, in case of React DOM, it will take this JSON on the left side and convert it into HTML. Of course, there are some transformations going on. You can see the style property that it's object on left side, your left side, I don't know, maybe it's right side, sorry, and converts it into this CSS string on the HTML side. So Voltra is basically doing the same thing. It's taking this representation, including native primitives, and it turns it into views on native side on both iOS and Android. So how can you build a React renderer? It's pretty much simple, because it turns out there is a package for that. And this package is used by, for example, React DOM. So it's called React Reconciler. And the thing you need to do when you want to use it is you need to provide this. Well, it's not big on this snippet, but you can trust me, this host config includes, I think, 40 properties. Many. And documentation is not really great. But AI will help you. I guarantee that. But in the end, if you look at the snippet, you will see create instance, which is basically function called if React needs to create some element. And then append child, which is basically, in our case, pushing to the parent, to the children array. And yeah, that's basically the foundation of Voltra. And with React Reconciler, you get all the hooks or the concurrent modes, pretty much everything that modern React supports. So we take this JSON, and then we create wrappers on the native side. So for our text, which is, let's say this JSON is Voltra node. And then for every type of Voltra node, we need to create a wrapper. And this wrapper is supposed to get the props, get the children, and render native views. And when we have that, the only part missing is basically creating Voltra factory, which will take Voltra node, it will look up the type, and according to type, it will produce different wrappers. And after doing that, if we run the code, you will see this hello world. So at this point, we have the core. Like, you just created a custom renderer that can describe the native UI and render it on the native side. But there are many, 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 many things missing. And one of the things missing is styling. So in React Native, we use style sheets, which are basically CSS properties. And on the SwiftUI side, we use something called modifiers. And if you look closely on the SwiftUI side, you will notice two paddings. That's not a mistake. And I will tell you why. Because it turns out that if you use padding, you will basically enlarge the bounding box of your component. So that's OK. That's the same as in React Native. Then you apply background color. So, well, the background will be red. That's also like the same in React Native. But then it turns out that if you want margin, there's no margin in SwiftUI. So you use the second padding, which will, again, enlarge the bounding box. But also it turns out that background color is not feeling like the current state, but only the previous bounding box. So things like this are all over the place in Voltra, because we are trying to make Voltra as close to the React Native mental model as possible. We don't want to force you into learning SwiftUI and, for example, Jetpack Compose on Android. We want you to use basically your React Native knowledge. So now let's talk about variants, because this is going to be interesting. So like I said, we need to support Dynamic Island. Dynamic Island has a couple of variants. Expanded, this big one, I think on your right side, I guess. The compact one with 2 icons on both sides, and the minimal one when the icon of our app is disconnected. So we need to provide some UI for all of these variants. So let's say we have API like this. OK, single root is going to work. So like the most simple way to now add multiple variants would be to do something like this, right? And it should work. We have multiple roots. Each will be used in different places, but technically it should work. Well, nope. It's not going to work. And the problem is that at this point, I thought that Voltra is not going to happen, because it turns out that there is a limit in the amount of payload of data you can provide from your app to live activity. And this limit is 4 kilobytes. Average image is about 400 kilobytes. So I was like, well, it was fun, but it's not going to happen. And then I thought that, OK, maybe we'll try to compress things. Maybe we'll try to shorten the properties. And we'll see what will happen, basically. So first of all, compression. So I used Broadly because it's well algorithm. The compression ratio of Broadly is good. It works on Node.js, on iOS, on Android. Perfect. It allowed me to shrink the payload size by 70%. But then I realized, oh, it's binary. So I need to convert back to ASCII to string with base64, which basically enlarges the payload size by, 30%. So in the end, I saved 30, but it's still good, but not good enough. So then I started playing with properties. I don't need font size. I need some short property which is unique, which I will then reconvert back on the native side to this long one. And the same can be applied to the type. I don't need the verbose type. I just need some kind of identifier. So numbers are perfect in this for this case because they only only a couple of bytes instead of a couple of bytes per let's say each character. But still, that was not good enough. It allowed me to shrink the payload size by 30%, but still, we were at the limit. So then I realized that, well, when you create React Native apps, we usually reuse the same style objects for multiple elements. OK, so while I'm rendering, I can check whether this particular style object was already present. And if so, I can move it to a shared registry and replace the style object with some kind of reference. So I did exactly this. And it worked. Again, it shrunk the payload size, but it was not enough. So then I realized I can use the same approach for elements. So this idea came from a real use case. So I shared Voltra with my colleague from Callstack, and he wanted to create something like GitHub contribution graph. Rectangles, colors, saying that you were a good guy, making a lot of commits recently. So he wanted to do something like this. And he was trying out Voltra. And basically, what I got back is this. So he was only able to do a single line of those rectangles because the limit was met. But if you look closely at the rectangles, you will see there are only a couple of them. A couple of variants. And the rest are basically clones. So with this element multiplication stuff, he was able to basically fill the whole space because, well, there are only 4 variants. So 4 definitions plus many, many, many references, which are cheap. And all of these changes allowed me to ship Voltra to all of you to use because now even with kind of complex UIs, you can use Voltra with all those optimizations. But it's always tricky to work on this stuff, because then I moved to push notifications. We need them, because app can be dead. And if it's dead, we cannot update the live activity. But on server side, we don't want hooks to be called. We don't want use effects to be called, because it will probably crash the server, because somebody will try to access window, for example. No concurrency. We don't need it. We just want to go through the rendering process once and then send the snapshot over to the device. Who knows what's the problem? This is the problem. You cannot turn off hooks for React Reconciler. It's basically not possible. So I was like, again, I need to do something. I need to recreate something. And it turns out that if you go to React DOM, to the source code, you will notice that there are two renderers inside of it. One is for the client side, which is based on React Reconciler. And the second one is a completely different one written from scratch. So I did the same. I rewrote Voltra to basically use, let's say, homemade renderer. And it sounds complex, but in reality, this is basically going down the tree, looking at the nodes, what types they are. So if it's a primitive, like string or number, I will just create an object and call it done. That's basically it. For arrays, I will recursively call the same function, because I'm interested in the children. So yep, that's the correct action for arrays. And if it's React element, I can check if it's a function. If it's a function, I can call it. So I will render it. And again, run throwers again as for the children. And this, of course, looks a little bit more complex in Voltra, because we have this tiled application. But this is the core. But then I realized, I need some hooks, because people want to use context to inject custom colors, for example, to their buttons. So I don't want them to be forced to use prop drilling. So yeah, I went into React this time to look for clues, how hooks work. This is real property. And it turns out that if you look up this property during rendering, you will find this age property, which includes an object containing all the hooks, basically. So for Voltra, I create my custom dispatcher, and I override this age property. Then I run my component to render it, and then I revert the change. So React Native can work just like before. And how this Voltra dispatcher looks like? Similar to this. So we will talk about context in a minute. But for state, we don't need state. So we basically take the init function, or just the object, and then we return it. And set state is basically no operation setter. For memorization, we don't need it, so we just call factories. For effects, nothing, because we don't need them. And this continues for all the hooks in the code base. When it comes to the context, you are probably aware that we have context providers and context consumers and use context hooks. So if we go down the tree and we find context provider, we can extract the context type and the value provided and store it in our context map. And then when useContext is called, we can use this readContext method to look for the value for given context. If it's there, we will extract it. If it's not, we will use the default value provided by in the code, basically. And when we go out of this context provider by going up the tree, we can just remove the value, the context type, and call it done. Basically, that's how contexts are implemented in React Native, more or less. And there are many, many problems like this. Like, working on this stuff is tricky because technically something simple, in reality, is not simple. So for example, images, like remote images. You would expect live activities and widgets to be able to basically fetch some image from, I don't know, some website. No, this is not going to happen. So what Voltra does is that it gives you prefetch API, so you can prefetch the image when your app is running. Then Voltra saves it to some persistent storage, so the widget and live activity can read from this persistent storage and display the image. And yeah, charts are pretty much the same. On Android, for example, there is no chart component, like no native chart component. So we created it from scratch. Actually, this was a community contribution. So we create image of a chart on Android when the live activity is rendered, and then we display this image on a widget. And it works. And it's like default way for having charts on Android. So if you want to have live activities and widgets in your app, you can scan this QR code, which will lead you to use Voltra, use-voltra.dev, which is the documentation site. You will find all the things you need in there. And if you want to contribute, then you can contribute. I will be very happy to see your contributions. If you want to follow me on X, there is my handle. I always post stuff about, well, I always post stuff about stuff I work on. Yeah, something like that. So, yep, you will find my handle here. And I hope that your React Native applications will be even better with Voltra powering their live activities and widgets. Thank you very much.